Welcome back, everyone. Here we are in section 9.2, where we are going to compare two means. Most of the time, we do not know either standard population standard deviation. So these are almost exclusively going to be t-tests that we do, which means we'll need degrees of freedom and all that, but we'll get to that. So two samples are independent. If the same values from one population are not related to or somehow naturally paired or matched with the sample values from the other population. Construct a hypothesis test of a claim about two independent population means. Now, for our purposes, we're going to assume that both standard deviations are not known, they are unknown. We're further going to assume that they are not equal to one another. Which means that they are not pooled, which will come up when we run the test in the calculator. And here are some of the requirements. What I just stated up here, where they're unknown, standard deviations are unknown, and we're assuming that they're not equal or not pooled. The two samples are independent. Both samples are simple random samples, and both ends are larger than 30, unless we know that both populations are have a normal distribution. And here's the hypothesis test. Here's the test statistic here. I show it to you here more out of mathematical obligation than anything. And as far as the degrees of freedom goes, it's going to be the smaller of the two samples minus one. And let's just jump into an example here so we get a better idea of what we mean. So the first sentence here is nothing more than just making sure that we've met all the requirements that I just read. So assume that the two samples are independent, simple random samples selected from normally distributed populations, and do not assume that the population standard deviations are equal. Again, that's the not pooled. The table gives results from a study of words spoken in a day by men and women. I'm sure we've all heard the stereotype that women speak more than men or something like that. So I don't know if these are real numbers or not, but I'm guessing that that's a falsehood. We're going to use a 0.01 significance level to test the claim that the mean number of words spoken in a day by men is less than that for women. So let's jump right into our null hypothesis there. We're going to assume that the two means are equal. And what they want to test is that the mean number of words that men speak is less than the mean number of words that women speak. And let's set up this is going to be a left-tailed test. We know that because it's less than. And here, that is 0.01. And let's get our critical value. Now, I want to point out that our degrees of freedom, remember, it's the smaller of the two. So that's this one here. So our degrees of freedom is going to be 186 minus 1, which is 185. So we're going to do inverse t here. Second distribution, inverse t. Now, if you have an older calculator, you may not have inverse t as a part of this. I will show you what you can do with that in just a moment. Area to the left is 0.01. And the degrees of freedom is 185. There is our critical value. So negative 2.347, we'll say. And if you don't have that in your calculator, you'll have to use this here. And you'll have to, first of all, I'm going to use this column, 0.01, and I'm going to go down. And notice we don't have 185. We have 100 or 200. 185 is closer to 200. So if we do that, you can see that we get 2.345 instead of 7. So it's close enough that we could use that. So you'll have to get a better estimate there. All right, so we are going to run in our calculator a 2-sample t-test. With this information, so stat tests 2-sample t-test is right there. X bar is 15668.5. 2-sample t-test there. 15668.5. Standard deviation is 8632.5. N sub 1 is 186. X bar sub 2 is 16215. Standard deviation 7301.2. And N sub 2 is 210. And this is a less than, so it's already on mine. It's not pooled. I've been making kind of a big deal about that, so we're not going to pool anything. And we're going to go ahead and calculate. And here is our test statistic. So T is negative 1.046, we'll say. And P is, I realized that I put some of the wrong numbers in to my calculator, and my t values came out a little bit different. So let me fix that. And I put the proper numbers in, these actual numbers, I missed one. I get that t is negative 0.6, let's see, 755, I guess. But the more important part is the p value. Oops, p value is here, which is the 0.25 to round it off. And the point is that is way bigger than my alpha. And you can see my t value. And you should double check my numbers, of course, is going to be way over here. I'm over exaggerating this, of course, to show that we are not in the critical region. But the point is that we're going to fail to reject. The null hypothesis. So there is not sufficient evidence to support the claim that men speak less than women. All right, let's move on to the next part. Now we are going to construct a confidence interval, and we're going to show kind of the same thing, actually. Meaning we should come to the same conclusion that we came to before. So here's all of the formulas, and what we're trying to do is find the difference between the two. And the idea here is we're assuming that there is no difference. Let me show you what I mean by that, because remember our null hypothesis is mu sub 1 equals mu sub 2. And if I subtract mu sub 2 to both sides, then we get mu sub 1 minus mu sub 2 equals 0. So this is our assumption. We're assuming that there is no difference between the two. All right, we are going to run into a slight problem with this. Let me draw this. The problem is our alternative hypothesis, if you remember, is that mu sub 1 is less than mu sub 2, implying that it is a one-tailed or specifically a left tail here. The problem with a confidence interval is that it has to be two-tailed because there's literally two tails. So here's what we have to do. Unlike what we've been doing before, we don't split that. We actually just add another tail. And what that's going to do, and again, we only have to do this when it's a single tail. If it's two-tailed, then we don't have to do this doubling. What that's going to do is that's going to change my C level. So my confidence level, I thought was going to be 0.99, but no, it's 0.98. That's what's in the middle here, 0.98. And I'm going to run a two sample T interval. Now, this is different than the previous one, and they're easy to mix up, is why I'm showing you this. Two sample T test versus a two sample T interval. So that's going to be in a different place altogether. So we go here, stat test. Now, it looks like I'm saying this, but no, I'm going to go to the intervals, and it's a two sample T interval. So that's different. Very nicely keeps all the data from the previous problem. But it asks for the C level, and it is 0.98. It is not 0.99 like you might think. Not pooled, calculate, and we get negative 2437, which is less than mu sub 1 minus mu sub 2, which is less than 1343.8. So here is our confidence interval, and here's the main takeaway that we want from this. We are going from a negative to a positive number. What that tells us, 0 is in there. At least I'm 99% confident or 98% confident that that's true. Right? If we go from a negative to a positive, that means that we're good. All right. Meaning we come to the same conclusion that the null hypothesis is not something that we're going to toss. So we're not going to reject the null hypothesis. So same conclusion. All right, this next one, we are going to do this two ways. We're going to do it using a test as well as a confidence interval. And let's go through this. A research project conducted trials to investigate the effects of colors and creativity. Subjects with a red background were asked to think of creative uses for a brick. Other subjects with a blue background were given the same task. The judges gave scores corresponding to a creativity marker. The higher the score, the more creative. The researchers test the claim that the blue enhances performance on a creative task. So meaning the blue should be larger than this. Now we got to be careful how we word this because I actually have the red first here and the blue second. So for the null hypothesis, you're going to assume that the two means are the same, meaning they're both equally creative. However, the alternative is going to be that mu sub 1 is less than mu sub 2, meaning the blue is bigger, higher marker. So we're going to test that at the 0.01 level. And we have a less than again, so that's going to be left-tailed. And that's again going to create that same type of problem when we get to the confidence interval where we'll have to double that. And the smaller n, so the degrees of freedom in this case, here's my smaller one. So my degrees of freedom are going to be 35 minus 1, which is 34. And let's get our boundary here. So inverse t again. 0.01, in this case, the degrees of freedom is 34. So it gives me negative 2.441 for my critical value. So now let's run our test. So this is going to be a 2-sample t test. Oh, I should mark this as, we're now doing part A. So we're going to find the test statistic and the p-value. And again, we're running the 2-sample t test. And we're going to input the data. So our first mean is 3.39, standard deviation 0.97. The first n is 35. Next mean is 3.97, standard deviation 0.63, and second n is 36. This is once again a less than. We are not pooled. We're going to calculate. So let's see what we get. And we are getting that t is negative 2.9, just say 8. Turn it off there. 2.98, and we're in the bad zone there. So we are in the critical region, it looks like. So I'm guessing my p-value is going to be less than 0.01. So p-value is 0.0021, which again is considerably less than our alpha, which is 0.01. So we are going to reject the null hypothesis. But before we do that, let's do part B. Where we do a confidence interval at the same level. Now, once again, we need to add a second tail here. So our C level is once again 0.98. So let's go ahead and run it. Stat, go down not to 2-sample t test, down to 2-sample t interval. And all the data is there again, which is nice. C level, it's again also 0.98. Here we go. So I'm guessing it's not going to become negative to positive like we did before. And I'm correct. Negative 1.046. Use of 1 minus use of 2. And negative 0.1142. So 0 is not in there. So no 0. Because we're going from negative to negative. So the previous one, we went from negative to positive. So that was good. So both the test and the confidence interval bring us to the same conclusion, is that we are going to reject the null hypothesis. So there is sufficient evidence. Is sufficient evidence to support the claim that the blue background is a little better. Kind of cool.